6.5, solving open sentences involving absolute value. So all that means is that we're still dealing with inequalities. We're still dealing with equations and inequalities, but we're going to have absolute value. So a quick reminder, the absolute value of any number is simply a positive number. So the absolute value of 5 is 5, but the same would be said of negative 5. The absolute value of negative 5 is 5. And it's all about distance between things. So if I'm dealing with distance, it doesn't matter if somebody's standing here and then somebody else is standing here. They're 5 feet away from each other. Like if this were a physics problem, I might want to think about him being negative 5 from the start and that guy being positive 5 from his start. But when I'm dealing with distance and a lot of different problems, I can just take the absolute value to remove all the negativity from it. So snakes, the temperature of an enclosure for a pet snake should be about 80 degrees Fahrenheit, give or take 5. So it's basically like it's 80 plus or minus 5 degrees. That's the range we want to be dealing with. But they say, well, solve this absolute value equation to find the maximum and minimum temperatures. So there are going to be two ways we set this up. Now remember how we talked about either a positive or a negative absolute value can give you a positive result? That means that in these problems we're going to write positive on the left, POS period, and then underline it, and then NEG period on the right for the positive and the negative cases. Now, as I first look at this, I don't see anything crazy going on the left side, like there's not squares or anything like that. So because of that, I can just rewrite A minus 80, and I'm going to set that equal to positive 5, because that inside will be positive 5. But on the negative side of things, let's say it ended up being negative. Well then, whatever's in there could also be equal to negative 5. So if it's 5, I get the same result. If it's negative 5, I get the same result. But I have to kind of just set up a second equation because I get two answers to these. And the more you practice these, the more they'll make sense. I'm going to add 80 to both sides. And I'm going to completely finish the left equation first, just like we did with those compound inequalities. And I get A is equal to 85. I won't bother writing degrees Fahrenheit. So that's where I'm kind of saying that if this is 85, 85 minus 80 gives me 5. We're good. And that would give me the max. So you don't have to write max, but that would be the maximum for this. But what if it was negative? What if the difference between those numbers ended up being negative 5, like to where I walked in the other direction to get that? Well, we set up our equation to where it was negative. I'm going to add 80 to both sides. I'm going to have A is equal to 75. And I guess the nice thing about dealing with a word problem like this, that's exactly what I said from the start. You know, it's going to be 80 degrees plus or minus 5, so if I went up 5, it would be 85. If I went down 5, it would be 75. And this would be the minimum temperature that should be what a snake should be living in for an enclosure. So find the maximum, find the minimum. I think we're good there. Let's go ahead and, I changed my mind, actually write the word max, write minimum by labeling those, and then we'll summarize our answer by saying A is equal to 75, comma, 85, and then degrees Fahrenheit. Whenever we have multiple solutions to something, we can write them separated by a comma. Now if I did end up finding that x was either 5 or negative 5, I'd rather have plus or minus like that. But here I can't write that because these are separate numbers. They're not the exact same. Okay, let's look at what these are without any real-world meaning, any word problem backdrop. So here's me writing b minus 1. Normally I would just draw that absolute value bracket first, but I'm showing that just to make it clear that these lines are drawn taller to where they clearly don't look like an 11. And when you're studying from notes and things later, if you want to be efficient when you go through your math, you don't want to have to look back at these and be like, oh, hold on, wait, did I write b minus 1 or did I write b minus 11? So make sure that before you move on to writing equals negative 3, pause this if you need to and make sure that's clear to you. So I'm rewriting the problem in that step. And then over here on the left side, I'm going to do the exact same thing we did as before, where the positive result and the negative result end up getting set up. But here is the issue. let's try to put something in here. Let's actually solve this. And this is going to be helpful to see. Here's b minus 1 equals negative 3. This is the positive case. I'm going to add 1 to both sides. And I'm going to get b is equal to negative 2. Now, let's actually check this. And we'll even label our check for these notes. Okay, I'm going to plug in negative 2. So here's me plugging in negative 2 to the original equation. Minus 1 is equal to negative 3. And then I'm going to have negative 3, but these absolute value brackets haven't gone away yet. And that's going to be equal to negative 3 on the right. And what's the absolute value of negative 3? Well, that's positive 3. And positive 3 does not equal negative 3. Now, if that's clear to you, then we can just simply jump to the end of this problem and write no solution. Because even if I were to work this one out too, it would be the same situation. You know, I wouldn't end up saying that anything can give me a negative result. So anytime you take the absolute value of something, you will never get a negative result. So these are going to have no solutions. And you don't even have to show work for problem 1. Like if you see that right away, you can write no solution, and then you can say you never get a negative from an absolute value. So here's the second absolute value equation. The absolute value of y plus 2 is equal to 4. I'm going to set up the positive problem and the negative problem. And let's ask ourselves this. First of all, are we getting a positive value after we take the absolute value of something? Well, we are, then there probably are going to be solutions to this. So rewriting y plus 2 equals 4. And then on the other side, we also know that y plus 2 could be equal to negative 4. Because if I take the absolute value of something that ends up being negative 4, I would get positive 4. So there's 2 solutions to this, like we talked about with the snake problem. Well, solving these early on equations are pretty straightforward. They try to limit it in the number of steps just so that you're focusing on the new concept. So here's y equals negative 6. Well, I'm going to write y equals, I like to see the negative because it's lower first, and then positive 2, and I'm going to summarize that all in one answer. So I've taken my first result, combined it with the second result, and written that in one single line. Okay, we have to check our answers. Let's plug negative 6 in. Negative 6 plus 2 is positive 4. And, I'm sorry, negative 6 plus 2 is negative 4. But then the absolute value of it makes it end up being positive, and 4 does equal 4. The next thing I'll show is what happens if we plug in a value of 2. Well, this one's easy. 2 plus 2 is 4, and the absolute value of 4 is 4. If you feel like it, make 3 an OYO problem, and you can pause this, but I'm still going to explain it like it's somewhat new. The absolute value of 3n minus 4 is equal to negative 1. Let's write our positive setup on the left, our negative setup on the right, and then we are going to rewrite the equation again. So here's 3n minus 4 is equal to negative 1, and then I just realized I should have planned ahead a little bit better and thought a little bit more. Now here's what you got to say to yourself. Am I going to change the sign on this and turn it positive? Nope, because there's no way you'll ever be able to plug anything in here and get a negative result. And maybe on accident, no, actually totally on accident, I move forward with that. That's a no solution. So that'll happen. You will end up bringing this up to a teacher, and then he or she will be like, you should have checked for the negative. But if you would get to the end of it and check your work, so here's me adding 1, getting 0, 3n is 0. That means that n has to be 0. Let's look at what happens when I put 0 in. 3 times 0 goes away, and then the absolute value of negative 4 is positive 4, and that does not equal negative 1. So these ones, when you check your work, you'll see, oh, whoops, I shouldn't have moved ahead. And that's because no matter what, you will never get a negative result when taking an absolute value. Now here's what's different though. Let's pretend the problem was set up like this. The absolute value of 3n minus 4 plus 8, let's say minus 8, was negative 4. Let's pretend that was the problem. Well, you wouldn't be able to set this problem up immediately. First, you'd have to get it to where the absolute value was by itself, and then after you do a little bit of algebra, you end up with an absolute value on the left side, and then a positive value on the right. So I don't want you going ahead and making like a universal assumption, and here's what I mean by a universal assumption. Just because you see a negative number on the right side of an equation, that doesn't mean that you won't be able to do some algebra first. So you have to make sure that the problems are always set up to where the absolute value is by itself on the left. We're going to work on these in a later video, so we'll stop this here and then you can resume the next video if you feel comfortable, or do some practice first.